Hi guys, so in this video we're going to be looking at how to map a standard SOP expression to a Karnaugh map. So SOP here stands for sum of products. So we're going to define that briefly, then look at how to map SOP expressions to both 3 and 4 variable Karnaugh maps. And that's what we're going to do. In the next videos we're going to cover converting from standard SOP to non-standard and also applying those to Karnaugh maps. So what is standard SOP? Boolean expressions usually come in one of two forms. The first one of them is SOP, so that's sum of products. So you have a sum of multiple products. And the other one is POS, which is a product of sums. So what this means is that you can have a binary expression. Let's say A is equal to, so that's, okay, so A is equal to, so let's use X, Y, Z. So you have X not Y, Z, or X, Y, or Z. So this is a sum of products. Since you're summing, since your primary X operation here is OR, so you're summing different products. And if B was to equal, let's say, X or Y, and Y or not Z, and X, this will now be a product of sums. So these are the two primary ways binary expressions come into play. So a standard SOP usually now means a Boolean expression where each term in the domain maps to each term in the function. So for example here, we said A is equal to X not Y Z or XY or Z. Okay, so our domain of variables here is going to include X, Y, and Z. Since these are our Boolean expressions for the output A. But this is non-standard because each term in the SOP, so that's term A, term B, term C, okay, so that's 1, 2, and 3. Each term in the domain is meant to appear in each term inside the expression. So let's say we had another expression saying C is equal to X, Y, not Z, X not Y, not Z, or X, Y, Z, or X, Y, Z. This will now be standard sum of products because each term in the domain here would now still be X, Y, and Z. And it contains each term, so that's X, Y, Z, X, Y, Z, and X, Y, Z. Each individual term that's being summed up to make the sum of products contains every expression in the domain. So it doesn't matter whether it is X or not X, or Y or not Y. As long as it has the primary form in each of these, then it's going to be standard SOP. So the reason we're covering this is that Karnaugh Maps needs us to be able to properly use sum of products, and particularly standard sum of products. In other videos, we're going to look at how to convert from non-standard SOP to standard SOP. But the scope of this video is just limited to applying SOP to Karnaugh Maps, understanding how to map them to Karnaugh Maps. Okay. So we have our first question. Map the following binary expression to an appropriate Karnaugh map. So we can see that this is a standard SOP because our domain, so let's say our domain here, is going to contain A, B, and C. Since these are all the binary variables in this, and each individual term has every member of this domain. So this has ABC, this has ABC, this has ABC, and this has ABC. So we can move on with that. So usually when you're dealing with 3, you will have something that looks like this: AB on one side and C on the other side. You can really change it up however you want to, but this is more of convention. Okay, so we know that this is 0, 0, 0, 1, 1, 1, and 1, 0, trying to maintain the one bit change that we covered in the gray code video to ensure that there's adjacency between each pass. Okay, so mapping this, we have not A, B, and not C. So we go to not A and B. Okay, so that's not A and B, that's here. And we map it over to not C, and we write it high as 1. Moving over to the next time, we have AB not C. So that's here, AB not C. We have not A, not not A, not B, not C. All right. So we go over to not A, not B, and add it to, and assert the part that has not C. And we also have not A, not B, and C. So that's over here. Okay. So that we can see that we had 4 terms in our output expression Y. And now, so this is our Karnaugh map. Okay. So K map. So we had 4 terms in our output expression, and we have 4 asserted boxes in our Karnaugh map. If we were to, we would definitely solve problems in other videos, but the point of this is to just learn how to map standard SOP to Karnaugh maps. But if we were to say, can we group these into prime implicants, as we're meant to do for Karnaugh maps, and we know that each group we're going to make can either only have 1, 2, 4, 8, and so on members, and we're trying to say, with the rules of adjacency that we covered in the first video, how will we be able to group this? So what I would do would be to group this way, and to group this way. So writing the other boxes as 0. Then this would be, so just to get the hang of it, let's see how we can write the expression for this. Okay, so now we can see that this expression, that this prime implicant is high both in not C and C. So we can see that doesn't depend on C. So we're looking at purely column AB. So this prime implicant is not A, not B. All right. So we apply the same logic to this. If we try and, so we know that this is the region where A is high, and this okay, and this is the region where B is high. Okay, because you can see here you have B high, and here you have A high. Okay, so you kind of look at it and say, all right, so this region is going to be B, not C. Since I have B and not C as the regions where it is asserted, since it cuts across both not A and A, then it's not going to depend on A. That's kind of the logic we use. So we can say that Y is equal to, the simplified expression of this would be not A, not B, or B, not C. It's as simple as that. And the final question we're going to do today is a 4-variable Karnaugh map. Okay, cool. We do AB here, CD, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. The point of this is to write in gray code, all right, to maintain adjacency. Okay, so filling this in is the same logic as we did before. So we have not AB, not A and B. So that's this row, and not C, not D. So we're going to write this high. We have AB, so you can really just break this into 2 and do the first 2 and the last 2 to sort of make it easier for yourself. So we have AB, so that's going to be this row, and C, not D. So that's going to be this. Okay, that's going to be this. Not A, not B, not C, not D. Okay, so that should be, okay, everything's off. Not A, not B, and CD. So that should be this. Not AB, so we'll go over to this row, and C, not D. Okay, that's this. AB, and CD. Not A, not B, C, not D. Not A, not B, not C, D. And A, not B, and C, not D. Yeah. So to sort of verify, we count that this output had 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we should be correct. So this is exactly what it means to map a standard SOP expression to a Karnaugh map. In the next video, we're going to look at given a non-standard SOP. So let's say we're given Y is equal to A, B, C, or B, D, or A, C. Okay. Given this, how do we make this a standard SOP? because the only way to map a variable to Karnaugh Map is if you have a standard SOP expression. All right, so we look at converting this to standard SOP, then mapping it to Karnaugh Maps, then finding out the minimalized solution. So thanks for watching.